All right, so first off, what's up? This is your old pal, Mr. Cook, and we are working on the Unit 10.1 notes. We just got through some of the basics with angle measurements. If you need a little refresher on that stuff, go ahead and watch that video. Now we're working on angle measurements and determining the measure of an angle. It looks like just based off of how the angle is drawn in standard position. So this is a big note, really important thing to make sure that you account for, and that's going to be the direction that the angle is going. And also the number of revolutions. So revolutions is one full circle. So full circle. And do you remember what a full circle is equal to in terms of degrees? Yeah, it's 360 degrees, and that's going to be the same as 2 pi radians. Really try to work with radians so you're more familiar with them. In the previous video, we went and had and used radians and degrees, and showed how to convert between the two of them. That's probably what I'll end up doing in this video, just to show you like an equivalent degree measurement, because a lot of you guys are more familiar with degree measurements. So I'll probably keep it like that for you, so it's a little bit easier to digest as I go through these problems. But I'm just going to stick with this section where we're just going over the angle measurements. So here's how you can tell the angle measurement of an angle that's drawn on a Cartesian plane. So first off, this angle is in standard position, so we just have the little arrow drawn to the right here, and then we have a terminal side that's pointing over here, and it gives us a little clue. It tells us that this angle right here is 80 degrees. Well, we're looking for this angle, this red one that goes from here, goes counterclockwise all the way to there. So is there a way to figure out what all of this is, this red angle right here, starting here, making its way over to there? Okay, well, if you think about it, together, this red angle and then this green angle here, they both make a full circle, and a full circle is 360 degrees. So the red angle is going to be all of 360, but short by this 80 degrees. So in other words, in math terms, we just take the 360 degrees and we subtract away the 80 to give us our answer. So 360 minus 80 is going to be, what would that be? 280? Yeah, 280 degrees. And here's another thing that's important, okay? So if you have an angle measurement that is going clockwise, then that means it's going to be a negative angle. If it is counterclockwise, and let's make that a little bit easier to write. I don't like writing 3 letters for clockwise. Let's just do CW for it. So when we say clockwise in the future, we'll just use CW, okay? So CW. And then counterclockwise is going to be CCW. Yeah. And when you do go counterclockwise, it's going to be a positive angle. So since this red angle starts here and then goes counterclockwise to its terminal side, it's going to be positive. So the final answer for this is that the angle that we've drawn is a 280 degree positive angle. Okay, let's keep looking through these. Well, this one's kind of a mess. So we're looking for the red angle, X, let's call it. It starts at the initial side, and then it goes all the way around once. So that's one full circle, 360 degrees. Then it goes through another full circle, get back to the same exact position. So that's another 360. So I have 360 and another 360. And then I've got this bit over here. Well, I've got to figure out what that extra amount is. It's obviously less than 360. So let's try and figure out what that might be. So the previous problem that we did, we kind of figured out what was left over with the red angle, right? We knew that the green angle was 80, and we subtracted from a full circle 360. You think that same kind of thing would work here? Because we already know that it goes through 2 full revolutions. So we have 2 of these 360s that we're going to add up. And then we got to add up this little tiny amount here. So one way that we can do it is recognize that from here all the way over to there is, almost a full circle, but it's short. It's short by this 55 degree angle here, and then another 90 degree angle over here. So to find that extra amount that we have, we're going to take 360, and we're going to subtract away 55, and we're also going to subtract away another 90. So if you get out your calculator, you can figure out what that extra amount is that we're going to add on there. So I'm just going to try and do this in my head. So 360 minus 55 is 305, and 305 minus 90 should be 215. So that means I'm going to add on an additional 215 degrees. Okay, so now I add up all 3 of the angles. So one revolution, one full circle, that's this one. and then another full circle after that. So that's the second 360. And then that extra amount, 215. So if I add all those up, I get a 5 here, and then a 13, and then 3 and 3 and 3 is 9. So 935 degrees. Now we just got to decide if that's going to be a positive or a negative angle. Since it's going counterclockwise all the way around, then it's going to be positive. So it's a positive 935 degrees. Okay, let's move on to the next one. It looks like this one's going clockwise because it's starting in standard position and making its way downwards. And it's also going to be answered in terms of radians. Okay, so here's where converting from degrees to radians may help you out. Some of you guys, could probably handle the fractions by yourselves. It's not terribly difficult to do. But some of you guys really struggle with fractions. So that's why I'm going to show you this little tip that I know about to make things a little bit easier for you. All you got to do, since we're just looking for the answer in terms of radians, is just convert this. It's kind of like a little bit of I don't know, like it's a little inconvenient to do this. I get it. But in the long run, it'll give you a right answer every single time. Okay. So if you just bear with me, and if you just do a little bit of extra stuff, then it might make it a little bit easier for you. Because this pi-4 may not mean a lot to you, but if you convert it to a degree measurement, it might, make it a little bit easier. So what we do is we take that radian value, pi-4, and we multiply it just like what we learned in the previous video, multiply it by 180 over pi to convert it into degrees. So if I multiply straight across, I get pi times 180 over 4 pi, and then the pi's cancel out, and I just get 180 over 4. And if you use your calculator on that, 180 over 4 is 45. So that angle right there, that green angle, is really just a 45-degree angle. And now this might be really easy for you because you might have noticed that this is a 90-degree angle. And so if I just take 90 and I subtract away that green angle, 45, that's going to give me the red angle that I need. So if I do 90 minus 45, that's 45. So this is a 45-degree angle. And, it should be pretty obvious. If we need to answer this in terms of radians and pi-4 is equal to 45 degrees, then 45 degrees is equal to pi-4. So our answer is pi-4. And we just got to watch out for whether it's a positive angle or a negative angle. And remember, to check that, we're going to see if it's clockwise or counterclockwise. So clockwise means it's going to be negative. Counterclockwise means it's going to be positive. Since the standard position starts here and then it moves its way downwards, that is clockwise. So that means that this is a negative angle. So it's going to be a negative pi over 4 radians. Okay, so we're going to do one more, and that's going to be the end of this video. So the angle starts in standard position. It looks like it goes through a full circle, so that's 360 degrees or 2 pi radians. And then it goes a little bit more, so it goes this much more. Okay, so let's see here. I know that this is 180 degrees for a straight angle, but it's short by this amount. So let's figure out what that is in degrees, and then we can probably figure this out pretty easily. So we're going to do 5 pi over 18 and convert it to degrees. So multiply by 180 over pi. So that's 5 times pi times 180 over 18 pi. So the pi's cancel out, and I get 5 times 18 over, 5 times 180 over 18. 18 and 180 are both divisible by 18, so this turns into 5 times 10 over 1. And 5 times 10 is 50. So it's just a 50-degree angle. Okay, so that's just 50 degrees right there. So if this angle, it goes from the blue to the blue, is the one that we're looking for, and if we go all the way around to this straight line here, it's 180 degrees, then all we need to do to find that missing bit for the angle is take 180 and subtract away 50. So that's going to be a total of 130 degrees. So we just simply add on 130, and that gives us our angle measurement. So so it's a 490 degrees. All right, but remember that it's asking for this in terms of radians, so we're just going to convert it back to radians. So to convert from radian to radians, we do 490, the angle measurement, multiply it by pi over 180. All right, so let's see here. That's 490 pi over 180. And then the zeros will knock off there because they're both divisible by 10. So I get 49 pi over 18. And it can't be reduced any further than that. So our angle is going to be 49 pi over 18. And now we just got to see if it's going to be a positive or a negative angle. Well, since the angle started by going downwards and then moving clockwise, that means that it's going to be a negative angle. So negative 49 pi over 18 radians is the angle measurement for this one. And I want you to keep in mind that, like, you know, the ones that we have, the examples that we have for number 2 and number 4 aren't going to be your typical angle measurements that you're going to have, like with a ton of revolutions. There might be like 1 or 2, honestly, on the more difficult one of these problems, but by and large, you're going to see more of the, you know, example 3 and example 1 problems. Okay, so that's it for just, you know, writing out your angles and figuring out your angles from a diagram. And then in the next one, it looks like we're going to move on to a couple more definitions of some new terms that we're going to need to know for this unit. Okay, so that's it for this video. If you need some help, make sure to reach out to your teachers and you know, contact them during their office hours and get some of the help that you need. Okay, that's it. On to the next video.